I like number 4. I like number 4.
All right. So to kick things off, I just clicked the record button for everyone in the room here. This evening, November 20th, 2018, the Power BI user group for Raleigh-Durham. We have Marco Russo joining us to talk about my Power BI report is slow. What should I do? All right, Marco, please take it over.
Okay, this is the screen.
Good job. That must have been really hard.
Can you confirm you see my screen, please?
It looks perfect.
Okay, good. So, good evening. My name is Marco Russo. The session for today is about performance in Power BI. And the goal of this session is not to teach you every possible optimization, because this takes a few days as a minimum. But the goal is to teach you where to start and how to identify whether an issue is a memory issue, a problem in the report, or a problem in the formulas that you might have in DAX, or maybe something else. So I will provide you a few tools that can be useful in this analysis so that you can save time focusing on mainly on the biggest problem you have instead of losing time in something that could be a problem but not the biggest one. Okay, so the idea is that I have a few slides that I can also share with you, but the slides are more a recap of what we will see. I have a few slides at the beginning just to introduce the topic, and then we will spend most of the time doing demos. My experience is basically about business intelligence with Microsoft Technologies for the for too many years, and I wrote several books, one in particular about DAX, and also do consulting and training about mainly DAX and data modeling for Power BI, of course, Power Pivot and analysis services. So the agenda for today is focusing on a few tools and a few techniques that we should learn to use in order to isolate the biggest bottleneck of a performance issue. So this is where we want to go, and in order to set up the stage for the problem that we want to solve, I have, let me open a Power BI report that has a performance issue. So now, of course, the performance issue we have in this report is not particularly bad, but the problem is if I had a real performance issue like something that runs in 30 seconds, it would be a pain, because every time we run the program, we have to wait 30 seconds and then we start again, and so it would be too long. Now, as you see, I open Power BI file. Now, you see an empty page, but the idea is that when I open the first time this file, I should see this report. Now imagine this, you open a report, you open a page, and look at the lower left, the bottom left area of the report. If you see, I'm talking about this area in particular. Let me see if I can zoom. This area of the report is a table that appeared a few seconds after the other parts of the report appeared. So imagine this is a bigger problem, not just 2-3 seconds like in this case. It could be 20-30 seconds. So the idea is that we just have something that is not so bad, because we want to retest this problem several times. And at this point, our problem is understanding why we have a performance issue, why something is low. So you open this file, or you open a page in PowerBI.com with a report you published, and you see this low performance. Now, in reality, the first thing that I look at this, when I look at this report, the first thing that I notice, look at how many visuals we have here. Now, having many visuals in the same report, many objects, even though they are very, very small with a single number, or maybe even just without any number displayed, it could be expensive, because when a visual in the report is tied to some data, for example here, this is connected to this measure, sales amount. This is connected to this measure sales amount, but with a different filter. So the idea is that who built this report said, okay, I use the same card visual, and for every measure, I apply a different filter. So what happens is that this report could be very expensive in terms of memory used. And my machine here has a 32 gigabyte of RAM. I will show you in a minute how I can detect this. But if I have a report that is taking too much memory, I could have a performance issue because my client is not able to get the memory required just to display the page. We're not talking about loading the model in memory. If I visit a web page, I will see exactly the same problem. So how can I investigate to understand if, first of all, I have a problem client side, because the client doesn't have enough memory to render all the visuals that are in the report. So the tool that we use for investigating on this is a tool that everybody has on a Windows PC, because it is the Task Manager. Task Manager is just a tool. You right-click on the taskbar in Windows, and you can open the Task Manager. And basically, what you can see is a list of all the processes that run in your machine, in your Windows session. So if you see, we have here basically one row for each window. Let me just sort by name, so we will not see this continue to change. The mouse is low, okay. And you see that I have other processes open, but basically this Power BI desktop file, the Power BI desktop application, is consuming 1 gigabyte and 200 megabytes. Now, how much of this memory is consumed just by the rendering, which will be the memory consumed also in your browser, Edge or Chrome or Internet Explorer. So, as you see, this application has 9 processes running. How can I see who are these processes? If I click here, you see a list of processes, and each one is consuming a certain amount of memory and also some CPU. This is also an important consideration. What does it mean? When I open Power BI Desktop, in reality I'm running a complete client-server system. So basically there are several processes that in an enterprise system are different processes in different servers, but here on my desktop are running on the same PC. And when you open Power BI Desktop, you have all these processes. What is the role of these processes? One is called actually Power BI Desktop. Let's say this is the coordinator of the entire system, and Power BI Desktop is actually the process that opens the PBIX file and loads this in memory, or at least it loads the file from the storage. However, the PBIX file contains several parts. Contains the data model, contains the data, and contains also the description of the report. What are the other processes running? First of all, we have a process called SQL Server Analysis Services. When you install Power BI Desktop, you are installing also a local instance of analysis services that is used exclusively by Power BI Desktop. You cannot use this instance of analysis services in a separate way, and this version of analysis services is always aligned with Power BI Desktop. So if you notice, the memory consumed here is double the size of Power BI Desktop. What does it mean? Well, the content of the PBIX file is loaded in memory, and part of this content is expanded. Actually, Power BI Desktop contains an analysis services data model. When you design a data model in Power BI, you are designing a data model for analysis services, and the tables and the content of the tables that you import in a model in Power BI Desktop are loaded there. Even though you use direct query, you still use analysis services, because analysis services is the engine for DAX, MDX, and in case you use direct query, you simply don't have data in memory, and every query that runs to analysis services is converted to queries in SQL to the data source. Now, in our case is we imported the data in memory, And as you see, this data imported in memory has a cost. In case you open a very large file, because you have 100 million rows or a lot of columns, you probably may observe a number that is larger than 1 gigabyte just for analysis services. But of course, with a small model, this should be a relatively small amount of memory. However, when you start running your queries, analysis services can grow in memory because some queries, some DAX query, could require a lot of temporary tables in memory during the execution that have to be allocated, and this has a cost. Again, why I'm stressing you about the memory? Depending on what you're doing, depending on the query, depending on the model, you may observe slow performance, but basically because you don't have memory. Now, in case you run Power BI on the browser, because you connect to powerbi.com, this service is running on a Microsoft server. So in that case, you should not be worried about this, but you can imagine that the same, if you have a memory issue on your desktop, the same memory issue can happen on Power BI, the service. And especially when many users open the same model, this could be a real problem. What are these other processes? The Microsoft Mashup Evaluation Container is the process that runs the M script when you import the M script of the Power Query transformation. So when you import and when you refresh the model, you will see that this process will consume CPU and memory. Whereas when you refresh the model, yes, analysis services consume CPU and memory, but you will also see that the analysis services consumes CPU and memory when you run a query. Whereas you will never see the Mashup Evaluation Container running CPU when you're running a query. I mean, when you browse your report, when you click on a slicer or something like that, because that process is used only when you import data, when you refresh the model. This console Windows host is actually something I don't know why it is used. Probably I think it is for the support of R and Python, but I'm not sure. But then we have these other processes. This is a variable number. Sometimes you see 3, 4, 5, sometimes more. And basically these processes are local engines of a browser. What does it mean? What we see here in Power BI, this area, the report area of Power BI, is basically an HTML5 page with JavaScript. Okay, so technically, the code that generates this rendering is JavaScript code that generates HTML5 and vector format. So basically, it is something that can run natively as it is also on any browser. This is the idea. Any browser that is HTML5 compatible. And when you're on the desktop, however, you don't need to open a browser. So what happens is that the Power BI desktop window creates a process that display a window that is the same engine of not the identical engine that you have in Edge, but something similar that runs in a window, even though it is executed in another process for security reasons. So this is the code that these processes run part of the area of the window that you see in Power BI, which means that when I see, for example, let me show you one thing. In a moment, I will click on this slicer, continent, and I will choose Asia. You will see that everything will spin here, and who will consume the CPU is both analysis services to provide the answer to the queries and these sub-processes that have to define the rendering for what you would see new. So if I go here and I click Asia, pay attention to these processes, okay? 1, 2, 3, 4, 5, and you see that this process also does something, because probably when I move the mouse here, the rendering required just to display the selected item must consume some CPU, some resource. Okay. Now, if I click on Asia, and I go back here, you see that this runs 9%, 4%, and at the same time also analysis services were running was running at 10%. Now you may think 10% is not much. 10% is, I still have a lot of memory. Well, it depends. My computer, if I go in performance and I show you not the memory but the CPU, you see that my computer has 8 CPU, 8 cores, which means that actually these are 8 virtual cores. I have 4 physical cores. With the hyperthreading are 8 virtual cores. What does it mean? Many operations, especially in the visualization and in the formula engine, which is part of the analysis services engine, can run on a single thread. So when I see something running at 10%, basically I'm already consuming 100% of one core. And sometimes I cannot scale more than that. So even though I have 20 cores, in reality many operations will not use more than one core on my machine. So for this reason, it is useful to notice that if I run something that requires 10% of CPU on my machine, 10, 20, between 10 and 12%, I'm already using the full capacity of one core, which means that if it is low, having more cores will not help me. Having a faster machine with a faster clock rate for the CPU will be helpful. Okay, so with this knowledge, now I can say, okay, when I click here, Europe, for example, I click Europe, and you see that this is running at 7%, 4%, 9%. I can see that basically I still have memory available. In case I had this process that was running the memory, also very high in memory, sorry, that was running the rendering, also very high in memory, something like 1, 2 gigabyte or more, then probably I have a report design problem. For example, when I see a report like this that has too many visuals, I am suspicious because if I use the custom visuals, the cost for each visual would be much bigger than this. Now, Microsoft in the last release optimized that, but until a few months ago, even just this report was consuming much more memory. And of course, when I consume too much memory, as I said, imagine you have a client with just 2 or 4 gigabytes of RAM. It's easy with 4 gigabytes of RAM creating a very complex report in Power BI that basically start to page memory to the hard drive or to the solid state disk, which is much slower than RAM, and this slows down the performance a lot. So basically, I'm now checking that, okay, based on the numbers that I see, I can exclude that I have a problem in the rendering of the report, but now I should be able to identify whether the problem is more caused by this process rather than by analysis services. In that case, it doesn't make sense to spend time looking at the DAX code. It makes sense to spend time looking at can I arrange the content in different pages? Because remember, if you have 20 pages, only the active page is the displayed one. Okay, so if you have 20 pages, you pay the price only for the active page in memory and queries. The pages that are not visible are not do not generate anything. So it is a good idea having different pages instead of trying to merge everything in a single page, because this could be very, very expensive. Now, what can I do? Now that I know that, okay, the problem is probably caused by analysis services, how can I identify what is the slowest measure, the slowest DAX code that is generating the problem? Because once I can exclude that I have a problem in the design of the report, I have to move forward with the next step. So at this point, I use another tool, which is called DAX Studio. So let me go back to the slide 1 second. We have seen the Task Manager, and now I will show you DAX Studio. DAX Studio is, sorry, I have a problem with the contact lens. DAX Studio is a open source, a free open source software. I just realized that the link here is the old one. Let me go to the new website, which is daxstudio.org. daxstudio.org. So here you can download this application and install it. But if you're interested in looking at the data source, as I said, this is the open source tool. So you can go on GitHub and you can see everything in terms of source code. You can also contribute to the project. It is written in C#, this tool. Now, if I open DAX Studio, give me 1 second, I have DAX Studio somewhere in my Windows here. Come on. Okay, here we go. So this is DAX Studio, and DAX Studio basically is this application that is very similar to SQL Server Management Studio as an idea. How can I use DAX Studio with Power BI? You see that you have a button here, Connect, that allows you to connect to a Power Pivot model, a Power BI model, or Analysis Services Tabular. In this case, we connected to Power BI. But I can connect only to a running instance of Power BI. So I'm not able to connect it to a PBIX file. The idea is that I have to run Power BI Desktop. Then I open DAX Studio. In case I opened several windows of Power BI Desktop, I will see here a list with more windows, and I can choose to which window I want to connect. What happens behind the cover is that DAX Studio searches for the Analysis Services instance that is running within Power BI Desktop and connects to that Analysis Services instance, because technically DAX Studio is a client for Analysis Services, just like Power BI. You can also see here in this area of the screen, at the bottom here, this number, 1042, is the port number of the connection string. So localhost 1042 is it is called by Microsoft the local diagnostic port of Analysis Services that can be used to monitor what is going on. Technically, this is a port for Analysis Services. I can connect any client to this port, but this number will change every time you run Power BI Desktop. So for this reason, we cannot store this string, or we cannot assume that this will be always the number. Now, we don't have to worry about this number because basically Power BI Desktop finds the right number every time for us, but this could be useful to, for example, connect to the same Analysis Services instance with other tools. For example, you could use Excel if you want. Now, what is we will use DAX Studio for these functions, which are here. But before showing you this function, I want to show you a very, very quick introduction to the features of DAX Studio, which are DAX Studio can show you the tables and the columns and the measures that you have in the model. For each one, it provides here in IntelliSense a few additional information, and it is designed to write DAX queries. So, for example, if I know the DAX syntax, evaluate, for example, segments, if I just write this and I click Run, I will see the content of the table segments here. What does it mean? The table segments is the table in the model, and this query simply is like a select star from a table, and I can see the result of this table. Now, DAX Studio has been originally designed to help developers writing DAX queries and developing DAX measures. But DAX Studio also has features that are specifically designed to help the debugging, okay, of DAX. For example, this first button, All Queries, can be used to listen all the queries sent to Analysis Services. Okay, so if I click on this button, I will see here a window, All Queries Open here, which now is empty. But at this point, DAX Studio, technically what DAX Studio is doing, it connects to Analysis Services like a SQL Server Profiler, intercepting a certain number of events. And the events that we monitor with all queries are basically the query end events, which are the individual DAX or MDX queries sent to Analysis Services with the duration, so how much time each query has been spent in Analysis Services. Now, if I keep this open and I go back to Power BI, so let me show you this. If I move this, so I have another window here, so I can show you this side by side. What I will do in a moment, soon as I can put my come on, this window. Okay. So if you remember, this slicer is selected on Europe now. Now, if I select on Asia, nothing happens. And you see that also the answer was very, very quick. Why? Power BI has a local cache at the report level. If I requested the same slicer I requested in my session 5 minutes ago, 20 minutes ago, Power BI says, wait a minute, I already asked for the same query. So there is no reason why I asked for this query again. I can reuse the results of the last selection. So in order to see some queries, you see that this window is still blank. The window behind here is still blank. If I click on North America, what happens? You see that this takes more time. You see that this wheel is spinning, and it's spinning for a few seconds. And in fact here, I see a number of queries that ran on analysis services. Each of these queries corresponds to one visual. And you see that if I sort these queries by duration, one of the queries, this one, spent 3 seconds, and I can tell you that this is the slowest query of the entire report, and all the others spent up to 20 milliseconds. The number that you see here in the duration column is a duration in milliseconds. Now you see that there are a number of information here that sometimes are not really necessary for Power BI Desktop. For example, the username and the database name cannot change. But when I use the same tool on analysis services where I have multiple users and multiple databases, well, at that point I can intercept the entire traffic of all the queries running on analysis services. Now, why am I showing you this? First of all, with this information I can see that all the queries are relatively fast. There is no point in trying to optimize a query that runs in 20 milliseconds. And the reason is that the precision of the measure is 16 milliseconds. So basically we are measuring noise. Any number there is probably almost random. So we cannot trust that number too much. Because plus or minus 16 milliseconds, we just don't care. And so we can realize that we already have a problem, because if we have 100 visuals in a page, we will have 100 queries. Even though each query runs in 20 milliseconds, it is already 2 seconds to refresh the page. So more visuals, more queries, more latency, more communication between client and server, more time. But let's say that in our particular case, this amount of time is not much. We can live with that. But this one is 3 seconds, which is already something that we don't like. We say 3 seconds is too much. However, I realized, wait a minute, but in reality, my original problem was when I opened Power BI the first time, with the settings I have in the initial page, I have a very, very bad performance. And once Power BI is open, it is much faster, but at the beginning is very, very slow. So how can I optimize the beginning? Now, the problem is that how can I capture the query at the beginning? Because if you think about this, I had to open Power BI and then I had to connect Power BI Desktop. So in order to connect Power BI Desktop and capture all the queries, also the first one, I needed to suspend the execution of any report. And what is the best way? Because if I open this report again, I will lose the first queries. But if you remember, when I opened this report, I didn't show the sales page. I shown the empty page. And the empty page is completely empty. What does it mean? If you create, imagine this, if you don't have this page in your report, you have only this page sales, you say, how can I capture the first queries when I run this? You have to do this. You create an empty page and you save the file once you create the empty page, or once you set the empty page as the active page. The reason is that if you forget to save after you selected this as the default page, for Power BI, changing the page is not an action that changes the file. So Power BI will not ask you, do you want to save? I had to remember I want to save. After I save this page, I can close. And when I close, of course, I lose the connection. If I try to do something now, I will see that the connection is lost. You see, connection timed out. So now I open Power BI again, but this time my empty page will be visible, and before I switch to the sales page, I will activate the connection and the all queries setting, so that I will make sure that I will capture the first query. Here we go. This is my empty page here. So if you remember, empty page, nothing has been done so far, just the model has been loaded in memory. So I can connect to Power BI this way. Then I can click on all queries, and I can wait that the trace starts. The trace started. You see here the messages. Trace started. When you see this, I can go in all queries. And just to make sure that I don't pollute my result, I clear the previous queries that I ran before. Now I'm ready. I go to Power BI, and I click on Sales. This way, I'm able to capture all the queries that run in Power BI Desktop, including the slowest one the first time that it runs. Okay? Now, I made a mistake. I made a mistake because I saved this slicer to North America, which is not the slowest execution. So now I go back here, and I repeat the entire process, because, of course, I want to find the bottleneck in the worst possible condition. And the worst possible condition in my report was an empty selection. So now I clear this. I open Power BI again. And, okay, sorry, I have a problem with the contact lens. And, okay, it should work. Here we go. So this is my Power BI Desktop. I connect. I start all queries. Query started. Okay, ready. Save. Now this is the slicer where I don't have any continent filtered. So this makes this query the slowest one. And in fact, you see that this area appeared now. And I see here the query that is the slowest one. Now, at this point, we imagine this. Now, in this report, the situation in reality is very easy, because we can easily identify that this is the visual that has a problem. And we could easily identify that this visual has only one measure. And so probably this measure is responsible for the performance issue. But let's ignore this for a moment. Let's imagine that we have a lot of confusion. And sometimes, especially in complex reports, it is not necessarily the last visual that is the slowest one. If you have, for example, 30 visuals, and you had other slow visuals before, a few visuals are queued. So their execution could be the last one, but not because they are slow, because they had to wait other visuals to complete. Okay, so it is important to not just base our, idea, oh, this is the slow one. Pay attention to the numbers. Always believe to the numbers, because the numbers are an objective measure of what is slower. Now, at this point, imagine that we are not able to identify who is responsible, but here we see who is responsible. So what we can do at this point, we can double-click the line that contains the slowest query. So let me just close this, because I had to do. Okay, I double-click this, and now I can run the same query again. What does it mean? Basically, I can check what is the result of this query. With this query is the slowest one. I'm executing the same DAX query within DAX Studio, and I can check in the results pane what is the result of this query. Now, you should be able to realize that this is actually the same content that I have seen in the table. All the other visuals had only one value, but this content is actually a list of products with a list of customers. Actually, I see also an additional column, which is a column with a flag that tells to Power BI whether a row is the grand total or not, as this name suggests. But basically, the idea is that in order to populate the table that you see in Power BI, Power BI had to generate a DAX query that has been sent to analysis services. Analysis services provided this content, and this content is used in the Power BI to generate the table that you see in the page. So now we know that actually we identified that this content belongs to this particular visual. So we can see, oh, this is the visual that is the slowest one. And we also can simulate this execution here, which is very important, because at this point, what I can do is, okay, you can repeat the same for all the other queries. You can run the query. You can also format the query with this button, but this is not necessary now. What we want to do now is, okay, now we want to investigate on the measures that are used in this visual. So we know that this query is related to a visual, and we can try this just in DAX Studio, trying to see whether we can optimize something. Now, one missing feature today is, it would be nice having here in this query is generated by Power BI. So Power BI, with a comment that says visual number 32, or with a name or something. Imagine there was a comment that was helping me identifying the visual that is this one. So if I had an ID that corresponds to this visual, that would be very, very useful, because sometimes we spend a lot of time just to figure out what is the relationship between a query and a visual, especially when several visuals are very similar in the same page. But unfortunately, this feature is not available yet, but it's something that Microsoft is aware they should do something, because it's very easy. It would be very easy for them to add this comment. Now, because we don't have this, what we can do is we compare the result with the content of the visual. And when you have a chart, you have to figure out that every point in the chart is a line here. Okay, every point in the chart is a line here. So you have to map this way. Now, what can I do at this point? At this point, I can say, okay, if I analyze this query, what are the measures that I'm using? Because the measures contain the DAX code for your execution. I have two ways to do that. If I identify that this is the visual, I can see here in values what are the measures. For example, the measure is customers. Otherwise, I can go here in the query, sorry, not here, but here in the query, and I can try to look in the names used here, what is, in this case there is only one measure, but what are the name of the measures used. For example, doing this analysis in either the query or Power BI, I figure out that customers is the measure that is responsible for the performance. So what can I do at this point? At this point, I can go here and search for the measure customers. And you see that customers is a measure here. And if I go in this before evaluate is the keyword that starts the query in DAX. And I right-click this measure and I click on Define Measure. What happens is that DAX Studio copies the definition of the measure in Power BI within the query in Power BI Desktop. What does it mean? If you look at this code, calculate distance count, so let me just increase the font here. So this is the code of this measure. Calculate distance count filter. I will comment this in a moment, okay? So if I go back to Power BI and I search here in Power BI for the customers measures with the same technique, and I click here, you see that the definition of the measure is identical. Calculate distance count filter. This is the structure of the measure. What is this measure? What is doing this measure? This measure is counting how many unique customers have a quantity greater than 0 in the table sales. And this is causing a big performance issue. At this point, once I identify the measure that is responsible for that, I have to try to understand what is going on. So once I have the definition of the measure and the query within the same page, I stop listening to all queries, and I activated these other two buttons, query plan and server timings. I just checked that the query started. I'm not sure that this is working. Connection is not open. Okay, sometimes there is some problem, so let me just copy this code. New. Time DAX Studio has some bugs, so okay. So I just increase the font so we can read better what is going on. I restart the connection to Power BI, and I start the query plan and the server timings. Not working. Interesting. So let me start again. I'm using a pre-release of DAX Studio. Maybe I have some bug that. So let me start with the server timings and query plan. Okay, this time it works. Okay, so now these two panes listen to other events that are generated. That we capture for analyzing in more detail a single query. What does it mean? If I run this query now, for example with run, you will see that here query started. This timer is running, and now I stop it at 5 seconds and 600 milliseconds. You see here that the entire query has been executed in less than 6 seconds, and you can see in the results the content of the result. It's just a larger font because I'm zooming this, but if I reduce this, this will be visible like before. Okay, grand total, customers. So it's always the same. Now I go back to this because in reality what I created are these two panes, the query plan. And if you were expecting a graphical query plan like SQL Server, you will be disappointed because we just have this information provided by Microsoft, which are the logical query plan. The logical query plan is a structure that describes the query in a object in an object tree model, basically, where you can see a description at a very high level of what the calculation has to perform. The physical query plan is something that we could compare with the actual execution plan in SQL Server. So here there are a number of operations, and you see that every operation calls other operation and calls other operation. The number that you see here, records, is the number of rows that has been actually executed, consumed from a particular query. And when you see here cache, this row with cache is a request made to the storage engine. So how does it work? When a DAX query runs, it is executed in the formula engine. The formula engine is the high level of the DAX engine that actually knows DAX, knows also MDX, but it doesn't have the data. When it needs to retrieve the data, it has to call the storage engine. The storage engine could be the in-memory engine called RDUPUG, or it could be SQL Server in case you have direct query. But the structure of the query plan, the physical query plan will be similar. So here we see that we have 1050 requests which perform how many storage engine requests? Too many, actually. And so at the end, there is some other query, and the numbers that you see here are numbers that says, okay, this query requested 0 columns in aggregation and 1 column with the result of a measure. Same here. So basically, each query running here is requesting for just one value with some request. Now, usually the query plan is not very helpful because it is very complex. It could be very long. Imagine this. We have 1,000 lines just for this simple DAX query. But if I go to the server timings, I see another visualization that is much easier to understand because the server timings basically capture. Oops, sorry. I moved this to the wrong place. So let me go here. Okay. Server timings. Okay. This window collects all the individual requests made to the storage engine. So remember, the formula engine is a high-level engine that has to request data from the storage engine. And for resolving this simple query, the formula engine requested 1,052 queries to the storage engine. The total execution time has been almost 6 seconds. This is the total execution time in milliseconds. However, the execution is split between the formula engine and the storage engine. In a perfect world, we should have, most of the work in the storage engine, because the storage engine is multi-threaded and can actually get the advantage of the multiple cores you have in your hardware, whereas the formula engine is single-threaded. And so having a formula that is very slow in the formula engine means that, okay, there is something to optimize, and we are not taking advantage of the storage engine. Now, in this particular case, however, the execution is split. You see that we have 43% in the formula engine and 56% of the time in the storage engine. However, there is something very, very strange here. We see that we executed for a single DAX query, we executed 1,000 storage engine queries, which is strange. In an ideal world, I have one storage engine query for my result, maybe 2 or 3 if I had the subtotals, but no more than that. And each query should run. This model has a few million rows in the sales table, and I expect that a query on a few million rows should be just a few milliseconds. Sorry, this table probably doesn't have a million rows. Let me check, but this is a smaller one. So go back to the Zoom just to make sure, because I don't remember. It's not important, but just to give you, yeah, this table is just 10,000 rows. So this table is very small. For a table like this, a storage engine operation should be not even measurable, should be 1 millisecond, maybe less. I expect to see for 12 million rows, so 3 orders of magnitude more, I would expect a single storage engine query to run in 100 to 100 milliseconds. Okay, so this is the order of magnitude that I would expect from the RDUPUG engine, from the memory engine. So I have to explain why we have so many queries now, because this is very, very strange. And at this point, from here and after, you basically you have to know DAX because at this point I had to understand what am I doing in this measure that is causing this really, really high cost. And in this particular case, the problem is very simple. I'm using a table filter in Calculate, filtering a table that has many to-one relationships and applying conditional reality to only one column. So if you look at this, this is completely redundant. An equivalent condition to filter sales quantity greater than 0 is just this, sales quantity greater than 0. Now, if we need to write something that is semantically equivalent to the filter that we have seen in the previous line, we should embed this in a key filters, because in case the report had a slicer or a filter on quantity, we don't want to override that filter, something that was, I mean, this is the same behavior of the filter you see here, because we filter the table. Okay, so now, but the idea is that before solving this problem, I had to identify what was the measure responsible for the problem. Sometimes the measure is a measure that calls for the measure, that calls for the measure, so sometimes the problem, the performance issue is more complex than this. Sometimes it's not so easy to solve. But just to show you that a single mistake like this, and actually this is the second biggest performance issue I find in my job almost every day. If I run this query again, what I will see is that the same query producing the same result now runs in just 12 milliseconds. And why it runs in 12 milliseconds? Because it executed 2 queries. You realize if I execute 1,000 queries, the problem is that each query requires 1 to 10 milliseconds, and then you have to count the cost for calling, the the latency for each calls between the formula engine and the storage engine. We talk about small times, but once you multiply these times by 1,000 or more, it becomes visible, it becomes seconds. Now, by pushing the entire calculation into a single storage engine query, what I obtained is that actually in two storage engine queries. One has the distinct count customer key for each product, and the second has a distinct count for all the products. This is the grand total. Sorry, I show you this better because without the zoom, so let me just show you this. So the two queries are these two. The code that you see here is a language called XMSQL, which is a textual representation of the request made from the formula engine to the storage engine. And so you can partially read if you read some book or some documentation how to read this code. It is similar to SQL with just some difference. But actually, you see that we have product name, distinct count in this first query that joins the sales and product and filter by sales quantity, whereas the second one just does the same distinct count without grouping by product name with the same filter with the sales quantity greater than 0. Now, the syntax is not really SQL, but it is something that we can understand probably. And why this query is much faster than before? Actually, this is the expected performance. The first one was low because I was applying a table filter that was forcing the DAX engine to make assumption about my intention that required to do a very, very, very complex operation that was not very well performing in Power BI or also in other languages, in other products that use DAX. Okay, so the idea is that once I identify the query, once I create a query that reproduces the problem, I can run this query several times and I can check whether I obtain the result. And I can, if I can optimize the result. Now, one thing that I didn't test, however, is the following. Wait a minute, Marco. Maybe I was lucky. Maybe I was lucky because my result was in cache. Analysis services has a cache. Analysis services has a cache for each storage engine request. So the right thing to do when you simulate the execution of a query multiple times, you should always clear the cache, which is an operation that requires a few seconds in DAX Studio, and then run the query again. Now you see that when I run the query again, I don't see any particular difference. The duration is 2 milliseconds. Before it was 0. Yes, I saved in the cache 2 milliseconds. But you see that we have now 11 milliseconds in the formula engine, 4 milliseconds in the storage engine. If I execute the same query multiple times, I will always see different numbers because we are below the 16 milliseconds of accuracy of the measures. But the thing is that I improved my performance in this case because I found a better query plan. I found a query plan. If I look at the query plan here, instead of having multiple requests, 1,000 requests to the storage engine, now I have only one. And this one produces the 1,000 rows that I want to display. This is the ideal condition that I want to obtain. Now, because clearing the cache and run is so necessary, we have this option. We can set the clear cache and run here, so that every time we push the button, the system clears the cache and immediately after run the query. So this is another way to save time. Now that I improved the performance, what should I do? I simply remove this. I copy the code for this measure. I go back in Power BI. I select my measure customers and I paste my code. Remember, so far we didn't change anything in Power BI. We were just trying modifying the measure, modifying the result, modifying the query. We were just trying to understand what was the problem. Now that we understood the problem, we can save this query, and now everything is much faster. And my model, when I click on the slicer, you will see that I still wait just a few milliseconds to see the result. And I no longer wait a few seconds to see the result here, because I optimized my query, and my measure, sorry. So at this point, I can go back to the slide, and I can show you what we have seen so far. We have seen that DAX Studio has a DAX query editor that allows me to write DAX code and to execute the DAX code. DAX Studio is integrated with DAX Formatter, which allows me to format the code in a more visible way. This is especially useful when you have measures that are written without proper formatting. And we have seen how to capture the queries, the queries generated by Power BI in DAX Studio. You will find in the slides. I will check how to share the slides, but basically you see in this link an article that describes the same steps that I did capturing the queries in DAX Studio. And one thing that I didn't show, and the slides always remember me that I probably forget, I have to show something that I forgot. So in this case, I forgot to show you another tool that can help us evaluating the numbers. We have seen that 1,000. Why 1,000? Why 1,000 and not 2,000 or 3,000? When you see these numbers, you have to understand whether these numbers are, make sense or not. Probably 1,000 is the number of products because we had one row per product. But when I have a complex model, how can I get an idea whether the number that I see makes sense or not? You have to know your data model. And knowing your data model means that you don't have to only know the data model in terms of tables and columns and measures, but also in terms of data distribution. You have to know how many rows, how many rows you have in a table, how many unique values you have in each column, because these are the parameters that can affect the query plan. So VertiPack Analyzer is a tool that you can download from this website, SQLBI.com tools VertiPack Analyzer, and it's basically an Excel file with a Power Pivot model that I'm opening now. Oh, sorry, I'm opening the wrong one. So 1 second only, I have to open Excel. And here we go. This is my VertiPack Analyzer. Now, this is a VertiPack Analyzer already populated with the data of another database. Now, I want to analyze our database, but let me just introduce what is VertiPack Analyzer, and then we will collect the data from our model. VertiPack Analyzer shows for every table the columns that you have, and for each column, the number of unique values you have in each column, and the size of each column. For example, okay, this table channel has only 4 rows. It's not really interesting. Let me take a look at this inventory table. So this table has 8 million rows. And this table has a total size in memory of 100 megabytes. Now, if I look at the content of the table, however, every column is different. There is one column that has exactly 8 million rows, just like the number of rows in the inventory table. Now, what can I see is that, wow, this column has the same cardinality of the table, and the cost of this column is 53 megabytes. Now, the entire table is 100 megabytes. One column is 50%, the primary key, which, by the way, is not required. We could remove this column from this table because we don't have to use this column to create we don't have any one-to-many relation with other tables, so probably this column could simply disappear from our model. So we can evaluate the cost of each column, and the reason why a few columns are smaller than others is because they have a lower number of unique values, so they have a better compression in memory. The compression is usually better if you have, can be better if you have a low number of unique values. But what we are interested to see is this number, this column that contains the cardinality number of unique values for each column. So at the table level, this is the number of rows in the table. At the column level, this is the number of unique values in the column. Then we have many other information that can help in evaluating other optimizations for very big models. We have a number of additional information about the relationships, the compression, but these additional information are useful especially for very large data models, for analysis services rather than Power BI, in my opinion. You also have a complete list of all the measures, all the calculated columns and all the calculated tables, and all the security DAX expression, the row level security DAX expression, filter expression that you have in a model. You can also format these measures here just for documentation. So it could be useful to see the list of all the measures also in a list here. And the final page simply has the instructions that tells you how to populate this model with the information from your Power BI model, which is what I'm going to do now. But remember, even though if I will be relatively quick, you can reproduce the same steps following the articles also linked in the page where you download the VertiPack Analyzer. So if I go to Power Pivot, VertiPack Analyzer is basically a Power Pivot model that is populated with the data coming from data management views of analysis services. And remember, analysis services runs within Power BI Desktop. Just to give you an idea, this is just another tabular model, which only has information about table names, column segments, data that is in the model, and so on. Putting all this information together, we populated the pivot tables that you have seen before. The step required to populate this model with the data of my model, my Power BI model, I have to change the connection to analysis services. And here, if I go to Edit and Build, I just have to fix the number. I have to find the window. Now the window is not visible. Why? Oh, here. It was in another monitor. Here we go. So this is the information I have to specify, localhost column number. Now, if you remember, we had this information in DAX Studio. So DAX Studio actually provides me the exact information that we need. And you see, because I restarted DAX Studio, this number, sorry, I restarted Power BI Desktop, this number changed compared to the previous example. So 1438. So I go back to VertiPack Analyzer 1438.
Where's he getting 1438? The lower right part of the screen. It was just below where his image was showing up.
Yeah.
On the screen.
Exactly. The number the number that I typed here, just to I heard someone asking. So the number I'm typing here was visible in this area. You see this low bottom right area of DAX Studio. Okay. Now I zoom in.
Status bar.
I show you. Okay, this is the exact part, the server name, localhost column 1438. But remember, this number is different every time you open Power BI Desktop. So once you do this, however, this is not enough. You also have to remember to go here, click here, and choose whatever number is visible here, because this is the internal database name used in analysis services. So you need both the data source and the catalog name. But once you have the data source, this can be found. Remember just to click and click, because if you don't do this, you get an error later. Now, once you do this, you can click OK, save, and just for efficiency, instead of refreshing the model here, it is faster if we go back to this VertiPack Analyzer tab, which is included thanks to a macro we have in the VertiPack Analyzer file, and I click refresh. At this point, what is happening? My Power Pivot model is creating analysis services that is running within Power BI, retrieving the data about the table name, the column names, and the number of unique values, and so on. And once this is complete, I can go back to my report, and I can see that, of course, my model is much smaller. I have only 2,000 products, and if I drill down, I have a smaller number of products here, and so on. So yes, actually, I would have expected 2,517 rows, but in reality, I see 1,000 because probably I have only 1,050 products used in the sales table. In fact, if I click on sales, if you see here, look at this number. I'm highlighting in yellow so it is more visible. If you remember, the product table has a one-to-many relationship with sales using the product key column. So the product key column in sales has only 1,050 unique values. So the entire sales table is using 1,050 products, unique products, whereas in the product table I have more than 2,500 products. So basically the number that I have seen in the physical query plan was exactly the number of used products in the sales table. And as I said, once you understand these relationships, when you see numbers of the result of a query, you can realize, oh, I'm actually iterating this or that or something else, especially when the number does not correspond to what you expect. Imagine that you expected to iterate 20 months, and you realize that you're iterating 2,000 something. Maybe that it is combining the month with something else, for example, and you didn't expect it. Or maybe that it is querying the data at the day level instead of at the month level, even though the visualization that you're running is by month, for example. And this could be caused by the time intelligence functions or something like that. But the idea is that you have to know your data model, and the easiest way to get the accurate data about your data model is using VertiPath Analyzer. So this is the part that I forgot, but once I have the knowledge of the data model, I can analyze the query plans in DAX Studio. We have seen the logical query plan, not very useful. The physical query plan, very useful but very complex. The VertiPath queries. The storage engine queries are where usually I start my analysis, because the idea is very simple. If I have a query that returns 20 rows and my storage engine query is returning 10 million rows, who is doing the aggregation? The formula engine. Or who is doing the filter? The formula engine. Bad idea. If I have this situation, I can imagine that the formula engine will be a problem, but the problem is not the formula engine by itself. Rather, the fact that my calculation was not able to be executed within the storage engine in a single query, like it was the case of my formula for counting the customers. So Tabular has these two engines, the formula engine that is very, very sophisticated but also slower and running on a single thread, and the storage engine, which is capable of amazing performance but doing very, very simple operation, and usually used to retrieve data from the storage engine in an aggregated way. So we have seen that running a query, now this is just the slide for a possible example, running a query we obtain a number of information. Now, DAX Studio simply display in a more easy to use and immediate way the same information that the SQL Server Profiler would provide. If you use this technique, using SQL Server Profiler instead of DAX Studio to collect the events is identical. You can use DAX Studio just to retrieve the connection string, but then you can use a SQL Server Profiler. And you will see for one query these many events. One event for the logical query plan, one event for the physical query plan, which is actually an actual query plan. So it is displayed at the end, not at the beginning of your query. Sorry, I'm trying to display this in your screen. Okay, so here we go. And then the final event is query end. What we do in DAX Studio, we basically collect these events, but we provide the same information in an easier to read way. And here the slide just recap all the informations that are available in the SQL Server Profiler. We didn't see the SQL Server Profiler, but SQL Server Profiler is the real data source for DAX Studio, the format collected by the SQL Server Profiler. Now, this is just an example that explains how to do the calculation of the execution time. So the idea is that, first of all, we isolate the query. Once we know the numbers that we may expect from our data model, we try to optimize the query, finding a better performance for our execution. You have seen that the critical part is the storage engine, because the storage engine is what can be also cached. And the result of a storage engine query can be persisted in memory and reused for a future request. This is what we call the data cache. And in fact, every query basically generates a data cache that then is consumed by the query plan. Now, why keeping the data cache small is important? the data cache is uncompressed in memory. The memory compression we have for the data in memory is only used by the storage engine. But if the storage engine has to provide some data to the formula engine, the data must be uncompressed. And sometimes you see a low performance in the formula engine because the RDUPUG engine is generating a huge table that also requires a lot of memory. But this memory has to be read by an engine, the formula engine, which is much slower than the storage engine. And this is another classical performance issue, which is also a scalability problem. The data cache uncompressed could be huge. So if you materialize a large table in a data cache, this could be huge. This is the reason why, not in this model, but in other models, we pay attention to these two columns, rows and kilobyte. These two columns tells you what is the expected result from a storage engine query. And if you see that the number of kilobytes is 1 million, that number is 1 gigabyte for a single storage engine query. You say, Mark, it's impossible. No, it's easy. You have a table that has 50 rows. You materialize 50 rows in memory for 1 million rows. Bingo, you have 1 gigabyte spent just for materializing a simple table that in compressed memory could be much, much smaller than that. Okay. So for 10 million rows, you may have 100 to 100 megabytes with all the columns, not just 10 columns. But it's just to provide you an example. Okay. So XMSQL is the language that we use that we see to describe a storage engine query. And it is a very, very simple language. It doesn't do many or complex operations. Basically, you have joins, where condition, and simple aggregation, where simple means sum, min, max, and count. That's it. You will not find, and listen count, of course. So one of the problems of analyzing the formula engine is that we don't have a clear indication about each cache consumed in the query plan, what is the corresponding storage engine query executed. This is another missing information. I've shown you that I cannot relate a single DAX query to a component, but within a DAX query, we cannot relate in a direct way a single line of the physical query plan to the storage engine query that correspond to that request. Again, this is something else that Microsoft should fix. And I also mentioned that the cache that you have in analysis services should be cleared before every execution, every test, to simulate the execution in the worst possible condition. You want to optimize your code in the worst possible condition, so that usually in a real environment it will be better and not worse what you tested. In order to clear the cache, there is a specific XMLA command to do that, but if you use DAX Studio, it is just a button that internally does what is needed to obtain the right result. So what we have seen so far is, what we have seen in the session is, when I want to optimize a slow Power BI report, first of all, I have to identify if I have a problem in the rendering, in the memory, or in the DAX code. Once I'm sure that I need to work in the DAX code, and believe me, I have seen many customers working for days on problems that were not DAX. For this reason, I'm trying to say it is just 5 minutes, to spend 5 minutes just to make sure you don't have another problem. Then at that point, you have to isolate the problem in DAX, possibly isolate a single query that you can reproduce many times, include the query measures in the query, in the DAX query that you test in DAX Studio, and then start to make changes to find a better execution time. Of course, what are the techniques to optimize the DAX code? Long story. We have books, white papers, courses. It takes hours just to describe all the possible combinations. But at least now you know where to start. Just to give you a reference, and then of course I'm open to any questions. We have 2 white papers about the query plans that you have seen in DAX, and a few chapters of our book, The Definitive Guide to DAX, that explain in more detail what is the meaning of the numbers that we have seen and what are the techniques that you may use to optimize the DAX code, where what I've shown you is just one of the few examples that you can find there. Any questions?
Oh, yeah, go right ahead.
My question was, can VertiPaq Analyzer be applied to all inputs or just relational database inputs?
No, if you imported the data in Power BI, once the data is in Power BI, you are using the VertiPaq engine, so you will see the queries in the XM SQL code, and VertiPaq Analyzer can provide you all the information, because it really doesn't matter where the data comes from. You may have entered the data manually in Excel, it doesn't matter.
Okay.
Okay.
Anyone online have questions? I see that we still have info of folks there. I see someone's typing, Sean is typing right now.
Are the slides going to be available?
Yes, I will send you the slide. Just I will send you to you the slide, and then you will put the slides available to the users. Okay.
Thanks.
Good. Just setting a reminder for that, otherwise I forget.
So I get the book links.
Yes, yes, the links to the books.
Slides. Okay.
What is a repro query?
Just to reproduce.
Oh, okay. A test query, yeah.
Test query, yeah. We say a repro query, but yeah, because you reproduce the usually we don't even say query. We say give me a repro. Okay. A query that reproduces the problem. Short name repro.
Snapshot, yeah.
All right, well, if we don't have any other questions, just want to say thank you, Marco. That was very informative.
Thank you.
Thank you a lot.
I also have the link to the Thank you very much. Thank you very much.
Thank you. Well, thanks for staying up late for us there, Marco. We'll look forward to seeing you online soon.
Okay, I will send you the slide in a few minutes.
Great, I'll share those out with the rest of the group. If you have questions, feel free to email them.